So, welcome to the Data Friday. My name is Michael Olschimke. I'm the CEO of Scalefree. We have this session here every Friday, 11 o'clock Central European Standard Time, to allow you, the audience, to ask questions about Data Vault, data-driven applications, data flows, and so on. Cloud services, that's all nice, good questions to be asked here, essentially. You can use the chat here in the client if you want to raise a live question. You can use the Q&A in the client. You can just raise your hand if you want, virtually. I don't see it when you do it in your room and you wonder why didn't you get voice. But if you raise it virtually, I'm giving you voice, works as well. You can also use a form, which I'll show you how you get there, essentially, after today's session. And then we also received a question, essentially, from one of the audience members. Let me just share it with you. Oh yeah, wait, sorry. So if we receive multiple questions, we go cherry pick. It's time boxed, roughly 10 minutes for good video, essentially, online. And if there would be no questions at all, I talk about the cluster. But yeah, I mean, we're coming out of a summer break, so we're relatively low on questions, actually. So if you have any questions, just shoot them, right? Now is your chance to get them answered quickly. So let me share my screen, because I have one question here. So this question is about HL7 FHIR messages, which are essentially produced in healthcare. And the question is essentially how to model these messages. And on the right, you see an example. It's a JSON message. And it's a complex JSON message because the structure is, it's really a semi-structured message. They have some definitions, but for certain different entities or events, the message looks different, essentially. And that's what, now I assume these JSON messages or JSON documents, they receive those via a constant stream somehow, either via batch or via Kafka, some message queue, but they receive these events or descriptions, essentially, these documents. And so the question becomes how to model this, because it's really complex. Just as a side note here, the database engine would be a columnar database like Vertica or Redshift. Let's focus on this first part of the question, then we might discuss this one here as well. So when we receive those complex JSONs, and in the standard, there could be also XML messages that you could receive and so on. So there might be different options, what kind of format you're going to get. Now, you guys know I like data flows. So in the morning when I wake up, I think about data flows, and in the night, I start sleeping my first dreams about data flows, right? That's the thing. So I think in data flows here. And what you receive is a data flow or message flow of JSON documents. And in the first step, in my first layer of the data model, would be what I would capture, essentially. So when you think about events, messages, the first data vault entity that should come into your mind is essentially a non-historized link. That's used to capture messages. So that would be my raw data vault, essentially. A non-historized link where I might have some hub references here. I'm not sure because I don't know the data format well enough. I assume they have some identifiers here, like the ID, for example, I assume, or the resource type. I assume the ID is a unique identifier in your message stream. So there could be it would be a transaction ID in a non-historized link. I would add that ID to the link structure itself, to the relation. But then I would have a data attribute or payload attribute of type JSON, or type JSON. I would do this for JSON. And I would just dump the document into this attribute. So I have a relational entity in my raw data vault, which is relational, but it's semi-structured because I have this data payload of type JSON. I wouldn't do it necessarily for XML. So I would prefer, and I assume for now, you're receiving JSON messages. The JSON support in many databases like Snowflake, but also in Redshift, for example, is good enough for this approach, essentially. So that's number one. Especially all the Postgres derivatives typically have a good JSON support. Like Redshift, Vertica are both Postgres derivatives. Problem is in Vertica, I just briefly looked it up. I couldn't. It looks to me that the JSON support is lacking in Vertica. That's my understanding, at least from a brief review, essentially, of the documentation. All right, so yeah, capture it as, and then you just capture the string. So the question is, how, in the next step, how you can parse the JSON. That's the key now. But get the message into the non-historized link. What I would do is this. I would also add some additional metadata from the message queue, like the message queue name, the name of the queue, the message timestamp or ingestion timestamp when the message was put on the message queue. You have something like load date. When did you receive the message from the message queue, and so on. So maybe a message ID from Kafka or from SQS and so on, right? Simple queuing service or whatever. So from your queue, some message ID, the timelines, all the metadata, essentially. That's the structure of the non-historized link. The metadata from the queue, the load date from the data vault model, the hash key across the whole message, right? And the some identifier here, the ID most probably here, and the ID attribute here, right? And then the JSON payload. That's my non-HISTORIZed link. There might be some hub reference involved. I'm not sure on this one. If you can extract for every message, regardless of what the structure actually is, patient, sickness, and so on. Is there a common hub reference? That would be the question. If not, doesn't matter. A it's odd that a link has no hub reference. I agree. But the non-historized links and the dependent child links, in those cases, yeah, might be the case, to be honest. Goal is to capture the data here. Now, once you have done that, you argue now, well, I would like to have some more data vault style to entities here, right? So maybe hub sync satellites. All right, let's do this in the business vault. We capture the data flow, but now you get, let's say, duplicates. You get multiple messages for the same patient because they modified the patient, right? Your first job is done. Get all the data into the raw data vault without losing any data, without artificially generating data. You've done it. We can reconstruct every message from the raw data vault. It's all good. Now you want to turn this into a hub patient with a satellite describing the patient with changes, data checking or something. What I would do is, first of all, identify the subset of the messages describing patient. So you need to apply a where condition. So we create a view in the business vault that looks like a hub where we select all the messages that refer to patients. And we know that here from the resource type most probably. So I'm selecting that subset essentially. That's where these JSON functionalities of the database come into play now. And then I would extract a business key, which is somewhere here. Let me just double check that quickly. Can't find one. But I bet there is a business key for like a patient number or something. Identifier for the patient itself. So that's what I'm extracting and essentially displaying as a hub structure, essentially visualized substructure. There's a question now with the hash key because we needed a hash key, right? But leave that apart for now. And then the next step would be to create a satellite. I mean, it's an easy game. So you select all the descriptive data that describes the patient and attach it to the business key or hash key from the patient hub. Just create a virtual satellite structure on top of these of the non-historized link with the JSON data, and then extract all the details you're interested in, like the code for the title or the what's here, the family name, the first name, and so on, right? The phone numbers and so on. Just extract those attributes and display extract them as a relational satellite with relational attributes. You know the structure for your patients, so that's much easier now, right? You don't need to deal with all these different structures. You're just dealing with patient structures now. You know the structure, get the subset of patient data, extract the relational attributes from the JSON, and display that, or the attributes from the JSON, and then display those as relational attributes in a relational satellite view in the business vault. And now comes the delta check. The thing is this: the delta check is used to reduce the storage consumption in the raw data vault, and with that to improve performance. But honestly, it's too late for that. We already stored the messages, right? And I'm not going to materialize the satellite. So why don't we just turn off the delta check? The messages are there. You want safe storage. So just, and the delta check, if you do it virtually somehow, would kill your performance anyway. So just don't do it. You could, even in a relational satellite, you could turn off the delta check, seriously. Just turn it off. You will lose the advantage of storage consumption, higher performance, but you could turn it off. And what happens is when you deliver the information based on those satellites, the PID table will close all the gaps for every snapshot date. So they will activate all these deltas for every snapshot date timestamp, right? And that will blow up the records again. So even if you reduce the deltas from the satellite, the PID table will then fill the gaps with the previous deltas all the time. So it will just reconstruct the whole timeline. And the end user will not realize it. The end user, based on the dimension, which is based on the PID table, will not realize if you have only one record for the patient because there was no change, or two records, and for day one in your information delivery, snapshot day one, you get you're activating the delta number 1 from the satellite, or delta number 2 for next day. They will not see any impact because you're only showing descriptive data in the dimension view. That's it. So you can easily turn off the delta check. That's what I'm doing here. I just create a view, extract the attributes, present those as a satellite attached to the patient hub. Done. Now, the question now is, what about the hash key? Because that's a bummer. The hash key we need to calculate, and the hash operation, you can't do that in a view. So a couple of options. First option is, especially on these databases like Redshift and most probably Vertica as well, those databases are MPP databases. And you could consider using a business key instead of the hash key in those models. Because these systems, I believe for Redshift for sure, I might need to double check this to be honest, but many of those systems, they hash the primary keys, the foreign keys, and the primary indexes of your entities essentially, in order to be able to perform joins across nodes. So that's essentially a Teradata. The strict comes from Teradata essentially, and that's why on some database systems we can use a business key. We don't have to use a hash key for improving the joining performance or having a consistent joining performance. Let's say. So on those systems, the business key might work, and so you could consider in this data model, instead of using a hash key for identifying hubs and satellites, you just use a business key. Solves that problem, number one, right? So you just use the patient key as your primary key in your virtualized hub entity, essentially. I mean, there's no primary key, but logically. So that would be an option. The other option, if you want to have hash keys, because we recommend hash keys when you have a environment where you have different database systems in play. Let's say Redshift in the cloud, but on premise, maybe a MySQL or Postgres, for example, Postgres on premise. In this case, the issue is that when you want to join across these systems, the hash key makes it much easier to join across systems. I mean, performance-wise. So you might insist on hash keys. In this case, you create a materialized hub table in the business vault, and then a loading statement. From all these messages, you extract the patient business keys. Again, subset the patient documents, get the patient numbers from there, and then load them, hash them into the business hub in the business vault. And then once you have that, you can then use a virtualized satellite in the business vault again. But you only get the business key from the document. So join the hub in the view, join the hub from the parent for the patient data, and get for the business key that you have, the hash key from the hub, and display that in the virtualized satellite structure. That's the basic idea. Yeah, so that's what I would do. And then you have a nice model, and then you can essentially go forward and do your thing in the information delivery, building your dimensions essentially with all the patterns we know. Data flows, guys. It's all about data flows. You receive messages, not patient data. You receive, patient data in messages, but it's messages, events, transactions. And the best model to capture those messages, events, is a non-instance link. That's my first layer in the raw data vault, and that captures the raw data, my data flows. And then I use the business vault to get closer to a business understanding of what you would expect from an enterprise data model, essentially. And you would expect hubs for patients, satellites describing patients, and so on. So I get there in the second step. And then I turn this into dimensions, facts, whatever. That's how our model is. Regarding columnar databases, we use this pattern on other database systems. I've used this pattern on Redshift, so I'm quite sure it works. Yeah, so but Vertica, I'm a bit of struggling, but especially because of the I believe missing JSON support. I'm not sure, to be honest. Or yeah, check this out. What the JSON support is, and that might also drive my decision which database I'm using, to be honest. At least for this design. Okay, if you have a question like this, there's a form where you can submit those questions. Use sfr.ee/dbfriday to submit your question. You can upload maybe some pictures from your whiteboard if you want, or team pictures, or good. Everything you upload might be published. So yeah, if you have a question like this, go ahead and submit a question here on the form. There's also additional webinars. One webinar on Westgate once per month, and one webinar on DBT. And those webinars you can register for at scalefree.to/webinars. That's where you can register just like this Data Vault Friday for those webinars. And check out the Data Vault community, Data Vault Innovator community. We set this up essentially with Ignition in Australia. Essentially, they also do the DVA trainings in Australia. And that's essentially where we get active and answer your questions in a community-style forum, where we also publish webinars, where we publish live sessions and so on. Also, great source for you to get support, help, to interact with the community. It's free, so just sign up, and it's where we offload our content more and more, essentially. All right, cool. Thanks for joining today. Enjoy your weekend. Good question, actually. I'm not sure if it came from Carl, but good question. And see you hopefully next Friday. Thanks, guys.
Thanks for joining today. If you'd like to discuss this further, give us a call on the number below here, and we're happy to discuss this with you. See you next time. Have a nice weekend. Bye-bye.